And welcome my wonderful honor students. This is your day 3 preparatory video covering displacement, distance, and position. You should have your notebooks open and ready to rock and roll. You're going to be writing down a bunch of things for me, some definitions. You're also going to be doing some basic math with me later on. And I'm going to have you pause it near the end multiple times to give you a chance to think about it and try to figure out what you should know before I confirm the answer with you. So let's begin. There are 3 basic vocabulary words you're going to be writing down for me. The first one is position, where an object is currently at the end of some time period t. As an example, think of someone who's running on a track. They start at the 100-meter mark and they end at the 250-meter mark some time later. Because of that, the symbol for position is x. The person who ran that track covered a lot of position. The position at the beginning and ends of time are kind of special. So the position at the end of the time are to call xf for x final. The position at the beginning of that time period is xi or x initial. In the above example, for the time period we said going from 100 to 250, xf will be 250, xi will be 100. And the time period between them is t. Now remember, the person could have started like even earlier, but it's only the beginning and end of the time period we're defining and that we're looking at. Next up is distance. Distance is the overall amount traveled during that time period t. So in the above example, the person traveled from 100 to 250, so it's 150 meters is their distance. And the most important, the one you're going to be using constantly throughout the year, is going to be displacement, which is how far you ended up from the start during time period t. So if you started at 100 and ended at 250, your displacement is 150 meters, which sounds the same as the distance. But as you're going to see, when we do more than one time period, it gets a lot more complicated. And displacements will be the thing we're going to use constantly to make it simpler. So, as a symbol, we use letter D for displacement. Distance doesn't really have anything, because it's not that important. Here's the mathematical equation. The displacement is your final position minus your initial position, which can be written as delta. That's a Greek letter right there. It's a triangle, delta x. So delta x down here just means this. It's a lot easier to write this than to write out final minus initial position. Let's see it in action. So here's a basic path, someone running around a lake or something like that. This is the starting position. This is the ending position. The person traveled a heck of a lot distance here. The displacement, however, is only how far it is from the beginning to end, which is a straight line path. So the person may have walked, let's say, I don't know, 500 meters. But the displacement is only how far it is from here to here in a straight line, which might be 125. So let's go in depth. Now during this point, if you need to pause, rewind, or do whatever to help understand it, you go ahead. I won't mind. So here's a number line from -5 to +5. There's an object that starts at 0. And then it goes to 2 in time period t1. So on the left-hand side, let's write down. In t1, its position is now 2 centimeters. Its starting position, xi, was at 0. It covered 2 centimeters of motion, went from 0 to 2. And the displacement, it's the change in position. So the final position is 2, the starting position is 0. So it also had a displacement of 2 centimeters. Now, the ball starts at 2, and then in the next period, t2, it's going back to 1. So going from 2 to 1 now in the next time period. So for time period t2, the starting position is 2, and the final position is now 1. The distance covered for time t2 is 1 centimeter. For the entire thing, it went from 0 to 2 to 1. That is a total distance of 3 centimeters. The displacement for T2, it went from 2 to 1. So final position is 1. starting positions 2, you have a displacement of negative 1 centimeters. That negative is super big. And for the total time period, the starting position is 0. The ending position is 1. So the displacement is 1 centimeter for the entire thing. You can see now how distance and displacement are now different overall. Distance is your total distance covered. 2 plus 1 is 3. Displacement, how far you ended from the start. You went from 0 and you ended at 1 after both time periods combined. So what have we learned so far? Distance is always a value, just a number. Displacement can be a positive or negative in value. And the overall values of these things are different than they are in the individual time periods. So we can either look at the overall, or we can look at individual chunks of it. So displacement has got a math equation where the values depend on the time period you're looking at. If you look at the overall, which we're now going to call average, you look at the total added up time. If you're looking at just a small little chunk, you can look at the beginning and end periods, or I should say positions, of that chunk. So let's do one example together so you can really understand this. Please pause the video and copy down that picture if you don't mind. So here we go. From A to B, what is the distance and displacement? Please take a moment and see if you can figure this out. Pause the video. Well, from A to B, going from 50 to 15 is 35 yards. That was one of my two cats. The displacement, the final position is 15. The starting position is 50, so the displacement is negative 35 yards. Once again, try it for B to C now. Pause the video. When you're ready, click play again. All right. So B we're at 15, C we're at 35. From 15 to 35 is 20 yards. And since the final position is 35 and the starting position is 15, you can see how D is now a positive 20 yards. Okay, Jock, so that seems pretty simple. Now, where it comes to the play is the next one. From A to C, what is the distance and displacement? But A to C does not mean going straight from here to here. Notice the time periods. The person goes from A to B and then from B to C. So this is really asking you to combine A to B and then B to C. Please figure it out. Press pause, and when you're ready, come back here. So here we go. So from A to B, you found it's 35 yards. From B to C, you found it to be 20 yards. So the total distance was 55 yards. But the displacement's a lot different. The starting position at the beginning of it, which is A, is 50. The final position at C is 35. Find the displacement. 35 minus 50 gives you negative 15 for your displacement. And finally, now from B to D, figure out distance and displacement. Reminder again, since B is at 3 minutes and D is at 10, you're going to go from B to C to D. Pause. Here we are. So what I did from B to D for distance is I found B to C is 20 yards, C to D from 35 to negative 5 is 40 yards, so the total distance is 60. The displacement is a lot easier to find, however. The starting position's at 15. You can see it here as xi, and the final position is negative 5. Doing that, I end up with negative 20 yards. With that all being said and done, you are now pretty competent at position, displacement, and distance. When you come into class, you're going to apply it a lot more. So ask me your questions, write down your notes for yourself, and have yourself an excellent day.